class today, and some of my students were preparing for their calculus exam, uh, and some of them were having trouble solving a particular problem. And that problem looked kind of like this. They were trying to solve the integral of e to the 2x times sine of 3x dx. And a lot of them were having trouble with this. And I went through and I talked them through it and helped them figure it out. But it got me thinking. What if we generalize this and change that 2 to an A and that 3 to a B? And I actually found out that there was a kind of pretty solution to this, and it looked really nice. So today we're going to be taking a look at how to solve the integral of e to the ax times sine of bx dx, and we're going to be taking a look at that using integration by parts. Integration by parts takes the following form. It's the integral of u dv is equal to uv minus v du. So in order to solve this problem, we're going to need to identify a function and a derivative inside of the original function, or inside of the original integral, and we're going to work with it a little bit, and we're going to manipulate it so that it takes on the following form, which may or may not be easier to help solve the integral. So in order to do this, I'm going to identify a function u that we're going to take the derivative of. I'm going to identify a function dv, which we're going to take the integral of. So over here, in our original formulation, I'm going to use u to be sine of x, b of x. And I'm going to use dv to be e to the ax dx. We need the dx in here just so we can finalize the actual integration itself. So let's take a step over here to the side and do some work. Okay. So the function sine of x bx is going to be our u. Sine of x b of x. And what we need to do is we need to take the derivative. So du is equal to, well, the derivative of sine is cosine of b of x. And because of the chain rule, we're going to have to pull this b out front because the derivative of bx is b itself. So let's do that here. B of x cosine of x. And then over here, we're going to take a look at dv. Well, we're going to use dv to be e to the ax dx. And what we're going to do is we're going to take the integral kind of both sides here. So the integral of dv would just be v itself. And the integral of e to the ax, well, that's going to be 1 over a e to the ax. And we're going to use this into our integration by parts formulation here. And we're going to try and see if we can make this a little bit easier. So let's bring it over. First by taking a look at u. So we need u times v. Well, u is simply sine of b of x, and v is going to be 1 over a times 1 over a e to the ax. And don't be like me, don't forget to write an equal sign here, because your teacher, professor, they're going to be looking for this. So what we're saying is this integration right here is going to be equal to the next statement below. And then we're going to subtract away the integral of v du. So v, once again, is 1 over a e to the ax, and du is going to be this b cosine bx thing here. And we're going to need dx to close that off here. Oh, I also forgot we need a dx here just to close off the fact that we know that it's a derivative. Okay. So let's continue down here and let's rewrite this statement. We have sine of bx times 1 over a e to the ax minus, well, we have another situation here that we can't just directly integrate. We're going to have to use integration by parts again. Now I'm going to take a look at this b and a. I'm going to pull those out in front of the integral. So we have b over a integral of, well, you guessed it, e to the ax times cosine of bx dx. Okay? And what we're going to do is we're going to do integration by parts once again. Well, we already have highlighted in red here cosine of x. So let's make a new u and have that as u equals cosine of bx. So the derivative is going to be equal to, well, the derivative of cosine is negative sine of bx. Don't forget the chain rule. So the derivative of bx is going to be b, and I'm not going to forget it this time, dx. We're over here, well, we need to highlight dv once again, and dv is quite simply going to be equal to our e to the ax dx, which should look familiar. We did this right above. So once again, we're going to be taking the integral of both sides of these. We're going to find out that the integral of dv is still v, nothing's changing there. And the integral of e to the ax dx is once again 1 over a e to the ax. So we can once again use this to create a new statement using integration by parts. So let's rewrite our original statement here. Sine of bx times, well, I'm going to bring this 1 over a all the way in front here. 1 over a, let's make it a little bit clearer. 1 over a sine of bx e to the ax minus b over a, and this is the integral that we've been integrating for our second round of integration by parts. So I'm going to wrap this in some big brackets here. Okay, I'm going to close that off with the left-hand side, and we're going to fill out the information in here. So we have u times v. U is going to be cosine of bx, and v is going to be, once again, 1 over a times 1 over a e to the ax. And then we're going to be subtracting away this v du once again. That's going to look like this. The integral of v, 1 over a e to the ax du. Take a look at this. We're going to have this minus sign here. So it's going to be minus b sine bx. So we're going to change that minus to a plus. It's going to be multiplied by b sine of bx dx. Okay, and that's good enough to close off our original statement here. So right here, this statement should look kind of familiar to you. If it doesn't, that's okay, because what we can do is we can pull this b and we can pull this a out in front of the integral. Okay, so that should look like, it should look something like this. It should look like b over a integral of e to the ax sine of bx dx. And this guy right here, what we're looking at, is actually the exact same integral that we've been trying to solve this entire time, which is kind of funny. So what I'm going to do is I'm just going to rename our entire problem. I'm just going to say, well, I, meaning integral, is equal to this statement here, this integral. So what we can do is we can replace this entire integral just with the letter I, just call it I. And what that looks like is, well, if I is equal to this, then I is equal to this, and I is equal to this, and I is equal to this. Therefore, we can finally say that I is equal to our original statement here, 1 over a sine of bx e to the ax minus, let's multiply everything in now. Let's multiply this b over a times cosine of bx times 1 over a e to the ax plus minus times plus is minus. And remember, these are the same thing right here. Okay, these are the exact same statements here. So what we have is b over a times I. So negative b over a times positive b over a is going to be b squared over a squared I. Okay. Now this is going to set us up really nicely for finally solving this problem. So let's get rid of some of the stuff on the side. Let's get rid of the work that you've already seen. And let's just bring it up using our magic arrow, come all the way around here, and let's just rewrite our statement up here. So what we have is I, and now I'm going to take this and I'm going to bring it over to the left-hand side. So I'm going to add negative b squared a squared times I to both sides. So if I add it to both sides, it's b squared over a squared times I, and that's going to be equal to all of this. Okay, so let's do some simplification here. I'm going to write it as e to the ax over a times sine of bx. And I'm going to multiply 1 over a times b over a. And remember, it's a minus, so it's minus b over a squared times e to the ax times cosine of bx. Okay, and I'm going to factor out, we have a common I on this for these terms right here. It's going to be I times 1 plus b squared over a squared. Okay. I just want to take a look at this right here. 1 plus b squared over a squared. Well, this 1 right here, well, that's the exact same as a squared over a squared. If you have a common denominator with both of these, then we can put these together. So we can change this entire statement here to something that looks a little bit nicer, a little bit more friendly. We can change it to I multiplied by a squared plus b squared all over a squared. And that's going to be equal to this previous statement on this side, which is e to the ax all over a times sine of bx minus b over a squared e to the ax cosine bx. And now you can see we have a squared on the bottom, we have an a on the bottom, we have an a on the bottom. So we can make this a little bit nicer too. So let's multiply both sides by a squared. So that's a squared multiplied by this side, and it's going to be a squared multiplied by this side over here. Okay, and what ends up happening is these a squareds are going to cancel out, and you're going to be left with I multiplied by a squared plus b squared is equal to, well, a squared divided by a is just going to be equal to a. So a times e to the ax sine of bx minus, well, a squared times b divided by a squared is just going to be b. So b times e to the ax cosine of bx. And you can see this is already starting to look really nice. So what we have is we have an e to the ax here, we have an e to the ax here. We can factor that out, and we can divide both sides by a squared plus b squared. So finally what we have here is we have I is equal to, I'm going to factor out that e to the ax, e to the ax. I'm going to divide both sides by a squared plus b squared over a squared plus b squared. And then we're going to wrap this in brackets. And what we're left with is a sine bx minus b cosine bx. And we'll close our bracket there. Starting to run out of room. So finally, our final solution to this problem is the integral, this I that we started with, is equal to something that actually looks really nice. E to the ax over a squared plus b squared multiplied by a sine bx minus b cos bx. And then finally, all you have to do is just add c, and there's your final answer. So I really like this problem. It looks really nice, for the plain and simple fact that it simplifies to something so pretty. Like you have sine of bx, which was in the original function here, and you have cosine of bx. So you can kind of see like a parallel drawn between the two. Like this is sine, then you take the derivative, and that's cosine. Well, not only the derivative of sine, but this is exactly the derivative of sine that you're subtracting away, sine of bx. So the derivative of sine is cosine, and the derivative of bx would be b. So the chain rule applies here. And it just looks nice, okay? You have a little a right here, you have a b right here, sine, cosine. You have this nice little closed off a squared plus b squared. And of course, adding, coming out in front here is just e to the ax. And it just really looks like something simple, something that is accessible to a lot of people. So I hope you learned something, especially using integration by parts here. And I'm sure there's plenty of ways to do it, which would be a lot nicer, probably a lot more simpler to um, go through, or maybe even a lot more elegant. So let me know what you guys think, and if you have any suggestions for future problems, let me know, and I'll try and tackle them.